which leads us on with efficiency to maintenance. And that follows on neatly. Eventually, your leaf nodes are going to be full. In this example here, we've got a very artificial example. Each leaf node can store only three keys, which is highly artificial. But we've got three. What if I now want to insert, say I want to insert Margaret. Margaret should be between Larry and Mary, but this block is full. So, next slide, we have to split it. We insert a block into the tree, and the existing keys divided 50-50, and all sorts of pointers are then changed. So coming back to this slide here, I want to insert Margaret, and there's no room for her. What Oracle will then do is find a free block of the index segment. It doesn't have to be physically adjacent, just a free block of the segment somewhere, and logically inserts that free block into the tree. How will it do that? Take my free block, adjust that pointer to point to the free block, adjust that pointer to point to the free block. And that free block is then logically inserted into the tree. Not physically moved, but because of these pointers, it will then be included in it. And up here, there'll be a pointer to that new block as well. Then Oracle will split the existing block, dividing the rows 50-50. Well, there are three of them, so I can't do it 50-50. But in principle, half the rows will stay where they are, and half of them will go into the new block. Then I can insert my new key, Margaret, into wherever she needs to go. So that's the standard block split. Existing keys divided 50-50, and lots of pointers change or set to bring that thing into the index in the correct logical position. If necessary, the parent block splits. Again, previous slide. I insert my new block here. That means this one is now pointing to 4 blocks. Not a problem. But eventually, that one will fill, and it will no longer be able to point to any more blocks. At that point, that one will then be split, and its pointers will be divided, and so on. Eventually, even the root block will be full. And at that point, we have to add another level to the tree. We're not moving anything. It's not a big task. It's only logical changes as you adjust pointers. But that's how indexes grow. You insert blocks into the tree, change the pointers. There's a change when it's at the right-hand edge. I mention this particularly because there's a lot of nonsense talked about indexes in the Oracle world. I'm sure some of you have heard that indexes degrade if you do DML against them, this sort of thing, that you have to rebuild indexes on a regular basis. No, you do not. The algorithms for maintaining indexes have improved hugely in recent releases, hugely. And to talk about rebuilding indexes because of DMLs and block splits and things, that's dreadfully 20th century. So, previous slide, there's a problem with blocks at the far right. Imagine this were an index on, say, a primary key generated from a sequence. You're only ever inserting new values. All your inserts were going to blocks at the extreme bottom right of the index. If that was split 50-50, you'd end up with a lot of wasted space. So for leaf nodes at the right-hand edge, there's a 90-10 split instead. So in effect, you add a new block and don't do anything else. So that's the block split mechanism, how B-tree indexes grow.